I have a MacBook Pro. It's 15 inches, and it's coming in as dead, which is low power. This is an A1707. This is an A1707. Depending on the device, the assessment or the troubleshooting approach will slightly change. So because this is an A1707, some of the common failure area is going to be different from the A1990. At the same time, it's going to be different from the A2141, which is the 16 inches. So the procedures we take will slightly vary. The rails that we check first will not be same with in what we check on the A1990 or the A2141. So if this was an A2141, we will be very much interested in the 2.5 volt line for the SSD, or we will be checking out the main PP bus rail, while the 2.5 volt line will be a sub rail to the PP bus rail. But in this case, the first with the A1707, these are some of so with A1707, some of the issues we want to look around. We want to look around U7800 to see if we have a short around U7800. That is number one. We are going to see if we have a short on the SOC line, which is a PP3B3S4_SOC. We are going to see if we have a short there. We are also going to look around to see if we have a short on the CD3215. Now, as you know, the machine has 4 ports. This machine has 4 ports, and then each of the port will have a CD3215 that controls it. So those are the 3 sections we are primarily going to focus on. However, one of the ways we can easily pass the 4 CD3215s is to see what is it that we have on our PP bus. If we have 12.6 in our PP bus, it definitely means that we have PPDC in. We are not going to worry about PPDC in. And then also, so if we have 12.6 on PP bus, we are not going to worry about PPDC in. If we have less than 12. If we have less than that, or if we don't have PP bus at all, then it means we are going to start by getting to establish the 20 volt on our PPDC in. So right now we are going to see if we have a short on our PP bus, check to see if we have a short around U7800, and then check to see if we have a short on on the SOC line before we actually connect power to it. Now, first thing we want to do is to disconnect the battery. Make sure there is when you're checking for a short, you make sure there is no power on that board. So I'm going to use a multimeter in continuity mode. The first thing I'm going to do is I'm going to be checking to see what is it that I have on my PP bus. I can use either of these fuses here, which are on my PP bus line, to see if I have a short. So I have my black probe on ground, and then I have my red probe on the fuse. Now with fuses, because it's a fuse, it means this fuse, both points are going to be equal because it's just a wire, correct? So whatever you have, so if I measure here, for example, if I get a beep, I'm not going to measure the other side because it's not a capacitor. If I get a beep on this side, it means the other side must also beep because it's a resistor. It's a fuse, unless the fuse itself is faulty. And one of the ways the fuse goes faulty is by breaking. So when it breaks into, it means point A will no longer be equal to point B. So let's see. Okay, we don't have a short. Now another thing also is sometimes when you're reading, even though you don't get a beep, when you get a low reading, a low resistance, so what you want to do is you want to use a diode mode just to be sure that your reading is accurate. So that is that. We know we don't have a short on our PP bus. Now let's see if we have a short on our SOC line. We can use any of these capacitors here. That's a beep. Okay, so we have a short on that line. So hopefully this is going to be an easy repair. So now with the A1707, again, I'm going to check it again. So with A1707, this is not the same like the A1990. With A1990, With A1990, we are not going to take this approach. We are going to focus on obviously the PP bus, which not necessarily the PP bus itself, but a sub rail, which is a rail that is powered directly or linked directly to your which is equal to your PP bus rail. That is going to be our focus because of C9081. But in this case, because an A1707s are 2016, 2017s, and A1707s, they don't have T2 chip. A1990 has a T2 chip, A2141 has a T2 chip. A1707 will have a T1 chip. Now, primarily, common issues that you want to be facing on the A1707, like I said, it's the approach we take is first thing first, we check our PP bus rail. It's not a common thing for you to have a short on your PP bus rail. What will be common, however, is to have a short around U7800. What will be common, very common, will be to have a short on your SoC line. So if you check that you don't have a short on your SoC line, the next thing you want to do is you want to check to see if you have a short on or around your CD32 15s. And then one of the ways, if you don't want to, because only one of the CD3215 on this side is easily accessible, the other ones are on the other side of the board. You might have to, you can just go ahead and connect power to it and see what is it that you have on your PP bus. So if you get 12.6 on PP bus, it means that your CD32 15s are fine. So yes, we've confirmed now that we have a short on this side, but that is not going to prevent your CD32 15 from working, and it's not going to prevent your PP bus from being activated. So let's connect power to the machine now, just for us to see what I'm trying to talk about. So yes, we're not expecting the machine to power on, but I just want to see what is it that we have on our PP bus. So we should be having 12.6 because the problem that we have has nothing to do with the CD3215. So the CD3215 should be powered. They should be getting 20 volt, which would then mean that they should be getting we should have in our PP bus to be 12.6. See that? So that is 12.6. Now now once I get 12.6, if I had not discovered that our problem is on the SoC line, I was not going to worry about the CD3215, because the fact that I get 12.6 meant that the CD3215s are working okay. Okay, so now we see that we have a short on SoC line. Now with the SoC, so commonly you have one of the capacitors here failing. So this, if we check on that line, the capacitors that are on that line are this guy, this guy, this guy. Now commonly, and then also on the other side, you find capacitors, you will find common capacitors that will fail also. However, the ones that I have commonly come across to have been the problem is this one here, this one, C4206. Sometimes you find that C4203, but most of the time the one that I have found is what? C4206. But that can as well change. You never know. You might have a different capacitor that fails on the line. So, but the first thing we're going to do is we are going to remove that capacitor. We don't even have to use so we're just gonna do this to remove it, and then you can always take the board out to complete the repair. So we'll do this. We'll be careful because there's also a resistor on that line. Okay, that cap is out of the board. We're not going to measure the cap by itself without let's measure the cap on its own to see if we still have a short. Okay, we don't have a short. It means if we don't have a short there, it means the problem is not that cap. Let's just confirm again. Okay, let's check on the board to see if we still have a short on the board. Okay, we still have a short on the board. So let's go ahead. We are going to obviously put back, and the reason why we took that capacitor out, it also doesn't look so good on one side of the capacitor. On one side of the capacitor. So nonetheless, which would mean even if it's not a problem now, most likely in the near future it's going to be a problem. Okay, so let's go ahead and remove the board and then check the other side of the board as well to see if anything stands out. Well, at least now we know that the problem that we have, it's a short on our SoC line. So let's quickly find out which component is responsible for the short on our SoC line. We address it, and this will be a happy repair. If this is the first time you are doing this, it's important that you take note of your screws. Take note of your cowlings. We had a similar issue like this one, and we removed the capacitor, and the one that we actually thought was the problem, and the short was still there. Then we went ahead to remove other components on the line that are connected on the same line, and it eventually turned out that the problem was actually the capacitor that we removed. But strangely enough, at the time we removed the capacitor, we made measurements and we still had a short on the line. So hopefully that's not going to be the same thing with this one. So before we remove any major component on the line, for example U4200, we are going to make sure that we measure for a short again and again, just to be sure. Because usually with when U4200 plays a critical role in your T1 circuitry. So when you have a problem on or around your U4200, so what will happen is your device will not boot to desktop, but rather will stop at critical update required. So you don't want to have issue around your U4200. Okay, board is out. Let's put the shell on the side. Oh, by the way, it's important when this is to be put back together to make sure you dust out the shell. Very important. Okay, so let's start and let's check the other side of the board. So the other side of the board for our SoC obviously is going to be on the side of U4200, which is in the same region as your U3900, your T1 chip. So let's see what's happening on the other side of the board. Let's flip the board to the other side. This is actually a 2016 board. The 2016 fits perfectly in the shell of a 2017, 2016. They look exactly the same thing, with very small differences in the chipsets in terms of the component placement. For example, on the 2017, you'll have a capacitor here. On the 2015 and the 2016, there will be no capacitor there. So that's just one of the easy way you can differentiate between a 2017 board and a 2016 board as regards the A1707. So with the 2017, you will have a capacitor here. Let me just see if I can get one for you. So this is a 2017 board. I see that capacitor, you will not find it here. See this one? The cap is not there, and this one, the cap is present. So that's the way to differentiate between the 2017 and the 2016. Other than that, everything will look exactly the same thing. Okay, let's see. see there's see if anything stands out on the SoC line. That has a little to do with the rail that we are troubleshooting. Okay, let's see if anything stands out. This capacitor here doesn't look good. This one does not look good, so I'm not sure. And this also doesn't look good. That is sitting on the SoC line. That I don't think is sitting on the SoC line, but we can confirm. This guy here, that's okay. It's an SoC, but not PP3V3 SoC. So that's the one that we are looking at. Now this one doesn't look good, but let's see. Let's check that one as well. Okay, that's fine. Yeah, okay, so let's remove this one. Yeah, let's see. So we are just gonna move it aside, or we can remove it, whichever one. Let's check the capacitor itself. Okay, alhamdulillah, that's our problem. So that capacitor is our problem. So the fact that it beeps means that it has a problem. So if it's not supposed to beep because it's a capacitor. Now let me just zoom out. So the one that we found as being a problem, it's the first one, so which is this one here, C4207. Now this is it. So if you look at the capacitor on the screen here, you see that it has what? Pin 1 and pin 2. Pin 2 is GND, which is ground. Pin 3 is the SoC, the 3.3 volt line, correct? Now when you see PP3V3 underscore S4 underscore SoC underscore PMU, now the first one is going to be the state when it's going to be basically it says PP3V3 underscore S4. What you want to take away is you want to understand the state where that voltage is going to be present, and the voltage itself is going to be 3.3 volt. The capacitor itself, you have there are three sections. You have 1, 2, and 3. This here, it's a material that separates 1 from 2. The way the capacitor will fail is that this material will no longer be able to create a separation between ground and the main part. If it's no longer able to create a separation, it means that pin 1 and pin 2 will become the same thing. Sometimes you have leakage. So sometimes you have leakage. Leakage will be that the material is still able to create a barrier, but not completely. In that case, when you will have a bit of this making its way here, you will have a short, but not fully apparent. Which is in that case, sometimes if your multimeter is not able to catch it, you want to use a diode mode, because even though your multimeter does not beep, when you use a diode mode measurement, it will pick it up. So the material here is supposed to, when the capacitor is working the way it should, is supposed to create a barrier between your ground and your pin 1. However, when this capacitor fails, the material will no longer be able to create a barrier. Then pin 1 will become equal to pin 2, which then effectively will mean that everything that is on this line will now be also connected to ground because of this capacitor. And in cases where we decide to inject voltage on this line, this capacitor here will become warm, or in some case will become extremely hot, because the voltage is directly going from this capacitor to ground. That's what. Yeah. So yeah, but this is the problem. We are just going to replace that, and let's just confirm now that we no longer have a short on that line. Okay, so we see that the short is gone. So let's quickly put back the two capacitors, also the one that we had taken off from here, and
still on.
say again? Yes. So this is not shorted, but I'm thinking it would be best to replace it. And then I'll just see, let me see some of those, also this guy here, that also doesn't look good. So I think it would also be best to replace it. If it doesn't fail now, chances of it failing in the future. So take that out. And then this guy's here. That's how many did I take out? 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. And the rest we took out. Okay. before you go out, remember to get a tweezer for me from Mr. Kane. And tell them to send me the updated bill. That fell off. Just get another one, please. Okay, and then the other side. Okay. Let's see if I have a working machine now. You see that? See how it broke that, just like that? Imagine if that was a Touch ID. And imagine how, I mean, those are two cables that broke at the same time. So it's
So I also broke one of this when I was putting on irons. Just this way.
so to be, especially when you are doing this, to be very careful. That's why, especially when you're on the Touch ID, you want to be careful. Just get another one quickly. I thought we cleaned that.
Yeah, you did.
Hmm?
You did.
Okay, just test the board and we can take it out and clean again. Okay, for this one, we don't need the battery connected in order for the device to start. So, and also because we have a sufficient charger in terms of voltage to be able to power the device. See, do we have a fan spin? At least we have the screen connected, one speaker connected, the fans are connected through the keyboard. Fan spin, nothing. Let's see, do we have feedback on our trackpad? We don't have trackpad feedback. Okay, let's use this one here. So what do we have on our device? 0. Does it mean the charger is not connected? Charger is connected. Charger is connected. Let's try again. Okay, something is going on. We're getting 0.9. That's which means we're having a problem. Let's see what is it. What's happening? Do we have a short? No, we don't have a short. So why? Let's check again. And PPDCN, do we have? Okay, let's take the board up. I'm not sure what's happening. Interesting. Which will mean we have 5 volt on our PPDC in. The question is why and fluctuating. Okay. That was a rail that was present before, but now we don't have it. PPDC in was 20 volt, but now we get it 5 volt and fluctuating. So a fluctuating line is a good sign, which will mean that the line is trying to boost. So let's check the second CD32. I think our problem might be this guy here. Remember I had cleaned I think our problem might be this guy here. Let's see. I think our problem might be this guy here, R3109. Yeah, because I found a bit of a corrosion here, which I did clean out. Yeah, let's just go ahead and replace that. So see how that pad is slightly gone. Oops. Okay, there you go. That's a 12.6. So the problem was this guy here was missing. I did see a bit of junk here, which I tried to clean off, but then the pad was already barely present. So 3.3 volt. This I2C PC_XA DBG. CTL_CL was no longer present because of a missing pad. That was because this pad here was missing, so there was nothing present here, which is why and then one of the reasons how you can easily detect that, for example, you see when we measured E3200 was fluctuating from 5 to 0. So what it's trying to do is it's trying to actually boost. So I mean, that was, and then I could remember, oh, actually, there was something on the line of one of the silicons 215, which I had addressed, and yeah, so let's try it again. We should have a working machine now. Okay, we're just gonna have the cables that we need connected. And one of the speakers. Okay, we have fine spin. Should have something on the screen shortly. And that's it. That's a beautiful Apple logo, and that's about it, guys. A quick summary. This is an A1707. Whenever you have a problem with the A1707, the approach you take in terms of your troubleshooting is that you want to focus your attention on the SoC line, which is where we found a short on the SoC line. Usually one of these capacitor will be my culprit, but in this repair it wasn't. It was on the other side of the board, which is the region of V4200. Just see that. So it was the region of the V4200, which is C4207. So at the same time, some of the components here were not looking so good, so we also had to replace those capacitors. And this one here also, C4231, I suppose, also was not looking either that or that, so we also had to replace it. And before we started the repair, we had found a bit of oxidation around R3109, which we cleaned off, but then that was barely, and the resistor was barely holding onto its pad. By cleaning it off, that actually affected its ability to take the voltage here to pass it on to the other side. After cleaning it, after we finished our work, we tried the device, it didn't start, and that was because instead of 20 volt, we're now getting 5 volt on our PPDC line. So we addressed that, and now we have a fully working device. That's about it, guys. Thank you. I'll see you guys in the next one.